So this was a pop quiz 20, which was related to moles and acid topic. So in the first question, a sample of nitrogen contains 1.204 exponent 22 molecules. What is the mass of this sample? The Avogadro's constant is given, which is 6.02 exponent 23. So how to work out the mass? First, we have the number of the particles. So from number of the particles, we have to find the moles. How we can find the moles? Because moles equal number of the particles divided by Avogadro's constant, which is 6.02 into 10 to the power 23. So we have the number of the particles which are given 1.204 into 10 to the power 22 divided by 6.02 into 10 to the power 23. This will give us the moles. And how to work out the mass? Because it's a nitrogen gas. So what is the mass of a nitrogen gas? Like nitrogen as a diatomic molecule exists. So mass will be 14 multiplied by 2, which is equals to 28. So then we need moles equal mass in gram over molar mass. If we need the mass in gram, so moles multiplied by molar mass is equals to mass in gram. So the moles, when we divide, this will give us the moles. So answer for this one, this will be moles and multiplied by the molar mass, which is 28. So the answer for this one, multiplied by 28, which is a mass of a nitrogen. This will give us the mass in gram, which is equals to 0.56 gram. So C should be the right answer for this. In the next question, when a magnesium oxide react with dilute sulfuric acid, write ionic equation. How to write an ionic equation? First, we write solid, liquid, and gas. It's a substance which is solid, so magnesium oxide is solid, and water is a liquid there. And in ionic equation, if one side it is like in a molecule, the other side it should be an ion. So oxygen is both side there, like magnesium is there, it's present in a molecule, so other side it should be a magnesium ion. Hydrogen is attached with oxygen forming a water molecule, so other side it should be two hydrogen ions. And so this is solid, this one is liquid, ions are always aqueous, so aqueous and aqueous. This is one way of writing ionic equation. The second way of writing ionic equation is first cancel the common ion in aqueous solution. So here sulfate is common, we cancel out. So we are left with two hydrogen ion and one magnesium ion. So the same answer we will get. So magnesium oxide reacted with two hydrogen ions. As a result, it will produce a magnesium ion and water as a liquid state. So B will be the right answer. In question 3, a solution of a sodium chloride is prepared by dissolving 10 grams of a solid in a distilled water and make up the solution to 250 cm3. What is the concentration? To work out the concentration is moles divided by volume. We have the volume of a solution, but that is in cm cube, so we have to convert into dm cube. To convert the cm cube into dm cube, we have to divide by 1000, so this will be 0.25. And then to get the moles, moles is concentration into volume. Or you can also work out the moles because you need a concentration, so you cannot use this formula. Then the other formula, moles equal mass in gram over molar mass. Mass in gram is 10, and the molar mass of a sodium chloride, as using a periodic table, sodium is 23 plus chlorine is 35.5. So you will add them, it will give us 58.5. So 58.5 is a molar mass. So it will be 10 divided by 58.5. Equals to 0.17. So we get 0.170 or 171. So 0.17 divided by 0.25 So the concentration will be 0.684. So B will be the right answer. In question 4, 10 test tubes each contain 1 cm cube of a chromium chloride solution of concentration zero point 0.1 moles per dm cube, and different volume of a silver nitrates are added. So silver nitrate plus the chloride ion from chromium chloride gives silver chloride. The precipitate were formed and allowed to settle down, and their heights were measured in the results. What is the formula of the chromium chloride? So how to work out this? This is the ratio between a volume, like first what we have to do, we have to work out, this is the height of the precipitate and different volume of a silver nitrate, it also have a concentration. So if I write the reaction here, chromium chloride is that we don't know what formula, like it is chromium 1 chloride 2, but it is reacted with silver nitrate. As a result, it will produce silver chloride plus chromium nitrate. Now, how we can work out, we'll simply take a ratio between, because here we have the, when we add 1 cm cube, the height of a precipitate increases, 2 cm cube, height of precipitate increase, 3 cm cube, height of precipitate increase, and then from 3 onward, the height of precipitate does not change. So what it shows what volume is react, because this onward means the reaction has stopped. So what we'll do, we'll work out the moles of silver chloride and we have the moles of chromium chloride, and we'll take a simplest ratio between them to know how many chloride ions are produced by this chromium. So first, to get the moles of chromium chloride, we have the volume and we have the concentration. So moles equal concentration into volume. The concentration is 0.1 and the volume was 1 cm cube. You have to convert into dm cube. So 1 divided by 1000, that will be 0.001. And when you multiply, you will get 0.0001. These are the moles of chromium chloride. Okay. And to then we work out the moles of silver chloride. How to work out the moles of silver chloride? Uh, what is the volume of a silver nitrate? Because this is the height of the precipitate, or even you can work out the moles of, this is a silver nitrate solution is added. So what is the volume of a silver nitrate for a complete reaction is needed? We have the formula, moles is concentration into volume. So concentration of the solution is 0.1 and the volume of a silver nitrate which is used for complete reaction, that is 3 cm cube. 3 cm cube we have to convert into dm cube, so 0.03. So this will be 0.0003 will be there. So what is the mole ratio? What is the mole ratio between chromium chloride? Like it was 0.001 and this is 0.0003. So when we take a simplest ratio between them, the ratio will be 0.0001. We divide both of them with the smallest value. So this will be 1 and this will be 3. So 1 chromium required 3 silver nitrate. So how many chlorides are there? Because each silver is reacting with one silver ion reacting with one chloride ion. So if we need 3 molecules of silver nitrate, how many chloride ions are present in this chromium? There must be 3 chloride ion present, because one chloride ion can react with one silver ion. So if we need 3 moles of silver nitrate, there should be 3 chloride ions to make the balance, because so this will produce 3 AgCl. So what is the formula of the chromium chloride according to this? So this will be D. Is it clear, this question? So what we did, we first work out the moles of chromium chloride, then we work out the moles of silver nitrate, and we use a ratio between them. If, like example, if our final answer was 1 is to 2, say our final answer was 1 is to 2, it means we need for like 2 silver nitrates are needed. So it means what is the formula? It will be CrCl2. So it depends on how, because according to ionic equation, one silver ion can react with one chloride ion. If we have 3 silver ions, how many chloride ions should be present in this chromium? It should have 3 chloride ions. In question 5, the element iron forms 2 chlorides, Fe2, iron 2 chloride and iron 3 chloride. A known mass of a iron powder, which is 200 grams of a hot solution of iron 3 chloride with a concentration of 0.5. When the reaction is complete, the solution contains iron 2 chloride and the unreacted iron is filtered, dried and reweighed. The initial mass of the iron powder and the final mass of the iron powder is there. Calculate the number of the moles that iron has of iron reacted. So how we work out, first we should know, because to work out the moles, moles equal mass in gram divided by molar mass. We need the moles of iron. So if we need the moles of iron, moles of Fe, that is the mass in gram divided by the molar mass. How much mass has reacted? We use iron powder 6.17 and after the reaction 3.38 is left. So how much is reacted? So we have to take a difference, 6.17 minus 3.38. This will give us what mass of iron is reacted. So 2.79 divided by the molar mass. You have to use a periodic table. Iron is 55.8. So when you divide, you will get 0.05 moles of iron reacted. Calculate the number of moles of iron 3 chloride that reacted. So we have the volume of the solution and we have the concentration of the solution, because like the hot solution of iron 3 chloride was there. Like this was iron 3 chloride FeCl3, which was having a volume of 200 cm cube and a concentration of 0.5 mole per dm cube. And in this one, we add iron until it is in excess or no more reacted. So we need the moles of iron 3 chloride. So how to work out the moles? We have the moles equal concentration into volume. So moles is concentration times volume. The concentration was 0.5 and the volume is 0.2. It was 200 cm cube, or we can say 0.2, because the volume should always be in decimeter cube. So when we multiply, we get 0.1 mole. Then use your answer to A1. A1, what was our answer? We got the moles of Fe, uh, the iron, which was 0.05. And the second one, we got the moles of FeCl3, which was 0.1 mole. The question is, use your answer for A1 and 2, write an ionic equation for reaction between iron and iron 3 chloride, including state symbols. You must show your working. Look, iron is added to iron 3 chloride. This is iron 3 chloride. And in the question, they mention when iron is reacted with iron 3 chloride, it form iron 2 chloride. That they mention in the beginning of the question. What is the state? We have to write ionic equation, but first I'm writing this was aqueous and iron 3 chloride was also aqueous. First, we have to work out the mole ratio. How to work out the mole ratio? As you can see, the moles of iron were 0.05 and this was 0.1 moles of iron 3 chloride. So to work out the mole ratio, We divide both of them by the smallest value, 0.05. We divide. So this will be 1 and this is 2. So it means 1:2 is the ratio. And the equation must be balanced. So it means how many. So this is a balance equation. We got first, we make a balance equation. As using a mole ratio, 1 mole of iron is reacting with 2 moles of iron 3 chloride to give 3 moles of iron 2 chloride. This is a balance equation. Now we have to write an ionic equation. How to write an ionic equation? To write an ionic equation, first you will write solid, liquid, or a gas. So we have only one solid is there, or you can cancel out the common ion in aqueous solution. So Fe is there, and there is no liquid or a gas other side. Then cancel out the common ion in aqueous solution. So chlorine is common, so you will cancel chloride ion. So here you was having iron 3, and here it will form iron 2. So this and state symbols aqueous and aqueous. So this is a balanced ionic equation for reaction between iron 3 chloride and a solid iron metal. Is it clear? Any doubt in this? Iron is also on both sides, but why we are not cancelling iron? Because it should have the same charge. Here iron is +2, Fe is +2. And here here Fe is +3. And here Fe is +2. So we cancel out the common ion, means with the same oxidation number. Because they don't have the same oxidation number, that's why I did not cancel out Fe. If Fe was having the same oxidation number in the reactant and the product side, then I will cancel out. But because there are different oxidation numbers, so we don't cancel them out. The concentration of a solution obtained in A is increased by heating it gently to remove some water. The solution is allowed to cool and a pale green crystals of a hydrated iron 2 chlorides form. Analysis shows that these crystals contain 28.1% by mass of iron. Calculate the number of the moles of water of crystallization for a hydrated iron 2 chloride. So we want to work out how many water molecules are arranged here. So in the question they mention 28.1% of iron is present by mass in the crystals, like the total mass. This is FeCl2.xH2O. So total of this 28.1% is iron. So first what we will do, like we will simply work out the mass of, like we'll calculate the relative mass of this whole compound. And as you can see here, the solution which we obtain for iron 2 chloride, and that solution which we obtain, we crystallize that. And when we concentrate and we form the crystals, and this will give us the water of crystallization. So we have FeCl2.xH2O. What we have to determine? We have to determine the value of X. Value of X, X is actually the water of crystallization. So the percentage of iron is given in the compound. So percentage of iron is equals to mass of iron in the compound, mass of Fe in compound, divided by the total mass of the compound. into 100. In the question, they gave us a percentage of iron that is 28.1. So the percentage of iron is 28.1. Mass of iron in the compound, we don't know, but we can work out this. How we can work out? Because there is one iron present there. So what is the mass of one iron? That is 55.8. So this will be 55.8. Total mass of the compound, we don't know. And this is multiplied by 100. So we simplify for x. So it will be 55.8 multiplied by 100 divided by 28.1. This will give us the total mass of this compound, like FeCl2.xH2O. The total mass of this compound is 198. So 198.58. That's the total mass of this compound, 198.58. Now, to know the mass of the water, how I can know the mass of the water? Like if I have the total mass of FeCl2.xH2O, if I subtract the mass of FeCl2, I'll get the mass of water. Why we need the mass of the water? Because using the mass of water, we'll work out the moles of water, and then we'll take a simplest ratio between iron 2 chloride and the water molecules, their moles, and then we'll know how many moles of water crystallization are there. So first we want to find the mass of a water. So mass of hydrated iron 2 chloride is 198.58 minus the mass of iron chloride. Iron is 55.8 plus chlorine is 35.5 multiplied by 2. This will give us the mass of water in this compound. When we simplify, so the mass of a water will be 71.77. Now we got the mass of water. So mass of a water, we got 71.77. Then to work out the moles of the water, moles equal mass in, because we will simply take like how many mole. Here we have 1 mole of iron 2 chloride. How many moles of water are used here? So moles equals mass in gram, which is 71.77 divided by molar mass of a water. That is 18. So this will be 3.998, which is approximately equal to 4. So means moles of water are 4. So moles of water are like 4 moles of water are present in this FeCl2.xH2O. So what is the value of x? The value of x is equals to 4. So what we did here, first we using a percentage of iron, we work out the total mass of a compound. Then from total mass of the compound, we subtract the mass of iron 2 chloride to know mass of the water inside. And then from mass of the water, we work out the moles of the water. And using these moles, we know that how many water crystallizations are attached to this iron 2 chloride. Is it clear? How we work out the moles? Anyone having a doubt or a question?